We are covering air quality for the FE Civil Exam, focusing on the National Ambient Air Quality Standards, or NAAQS, criteria pollutants, and the Gaussian Plume dispersion model. First, you must have the 6 criteria pollutants memorized. They are ozone, particulate matter, both PM₁ and PM₂.₅, carbon monoxide, nitrogen dioxide, sulfur dioxide, and lead. A great mnemonic to remember this list under pressure is P-console, which stands for particulate, carbon monoxide, ozone, nitrogen dioxide, sulfur dioxide, and lead. The exam will test you on the distinction between primary and secondary standards. Primary standards are set to protect public health, especially sensitive populations like children and asthmatics, while secondary standards protect public welfare, which includes things like visibility and damage to crops and buildings. Now let's shift to plume dispersion, which is a highly testable calculation-based topic. In the Environmental Engineering section of the NCEES FE Reference Handbook, you will find the Gaussian plume model equation. The most common exam problem will ask you to calculate the pollutant concentration at a specific point downwind from a source, usually at ground level. The ground level concentration formula looks complex, but it's a plug-and-chug problem if you know what the variables mean and where to find them. The concentration, C, depends on the emission rate, Q, the wind speed, U, the effective stack height, H, and 2 dispersion coefficients, sigma Y and sigma Z. A major exam trap is unit conversion. The emission rate, Q, is often given in kilograms per hour or pounds per hour, but it must be in grams per second for the equation, so be prepared to convert. Another critical point is the effective stack height, H. This is the sum of the physical stack height, H, and the plume rise, delta H. The exam might give you H directly, or give you the 2 components to add. Do not make the mistake of using only the physical stack height in the formula. The dispersion coefficients, sigma Y and sigma Z, represent how much the plume has spread in the crosswind and vertical directions. These values are not constants. You will determine them from charts in the reference handbook based on the atmospheric stability class and the downwind distance, x. The stability classes range from A for very unstable conditions like a hot sunny day to F for very stable conditions like a clear night with light wind. Unstable conditions cause pollutants to disperse quickly, leading to lower ground level concentrations near the stack, while stable, Class F conditions trap pollutants near the ground, often resulting in the highest concentrations far downwind. A typical exam question will provide the stability class, wind speed, emission rate, and stack heights, and ask for the ground level concentration directly downwind, where Y equals 0, at a certain distance, x. Your job is to find the correct sigma Y and sigma Z from the stability charts in the handbook. Carefully plug all the values with consistent units into the Gaussian equation and solve for the concentration, C. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.